All right, thank you guys. So typically with these flashback talks, what we do is we, do the same talk we did last time we were here. Last time I was here was like 2016. I decided to do something a little different. We're gonna do some of the stuff from before. So if you did miss that talk, you'll get to see some of it. We're gonna talk also more about like what's changed and what we can do and areas we could use some help on. Hopefully this slide thing will actually transition. I have a feeling it won't, but let's give it a shot. It kind of was there for a second. It's my VM that's causing an issue. All right, we'll try this for a bit. So when I was here last, is it still blinking? Doing its thing? Is it? I'll keep talking. But yeah, you go ahead and you want to play the rest? Here, you can do it.
Can you change the resolution?
You help me with this? Here. Okay, go ahead. I don't Mac either. That's the thing. Yeah, I'm also Linux. This is what happens when Linux users use Mac. I'm like, what the hell? It's just so tiny. Is this thing? Oh, yeah. Do you mind?
No, display. It is the resolution.
Yeah.
It's in display.
It's very tough to read. I'll keep talking when you guys do that. So back in 2016, that's when I was here last, and back there I was basically a consultant at the time, and so I was working for a lot of different OEMs, which are the car manufacturers, and some tier suppliers, kind of like trying to raise awareness and getting them better at some of their security things when it comes to automotive. I wrote the Car Hackers Handbook. I was working with the Car Hacking Village and DEF CON. Made a bunch of open source tools, released all those. The whole point of them is really to kind of lower the bar. Because I think for a lot of people, especially security people, cars aren't necessarily where they come from. They may not know like really how they work. And if you did work on cars, you didn't really understand how the software on them worked and those kinds of things. So my goal was to make it easier for anybody who wanted to kind of do those. I'm gonna leave it up like that. Yeah. Is it still blinking and whatnot? Still up. All right, that's better. That's working. That's nothing else going to blink. Cool. Wasn't there like a thing you pay extra for Mac to like make it work easier or something like that? Who here's from Apple? Get up here and fix this. All right, you guys can keep playing if you want. No, we're all Linux here. God, I love this conference. This is fantastic. So anyway, when I came and gave the talk before, I was on the automotive hacking, and we got a bunch of press for it. I think Forbes had articles, a bunch of other articles out there, kind of talking about it. And that was good. It was bringing some awareness. One of the things that we use these talks for, I mean, it's great to kind of talk amongst security teams like ourselves, because here, it's other people who kind of deal with the same kind of problems. They know how to fix these problems all the time, but it's still kind of like the echo chamber. I talk to you guys, hey, we need to fix these security things. Like, yeah, like that sucks. But it doesn't really necessarily fix them. And so one thing I highly recommend doing if you want to actually try and fix an industry is start giving these kinds of talks or any kind of security talks. You might have to make it not super technical, but give them actually at those industries. Those industries do have their own kind of conferences. And so with those conferences, you can, go and, they typically have like things where they say like, oh, well, here, and like say it's an automotive conference, like, this is how amazing we're doing. This is all the cool things we're going to build and whatnot. And this is still killing me. And but if you come in there and you start telling them like, hey, things aren't all good. There's a lot of things we actually have to fix. One, they're usually not terribly happy with you. But at the same time, they do listen. And they do, they'll argue maybe a little bit. But in general, it does make progress. And we get a little bit farther. But one of the ways that these automated tools work is they actually work on a system called CAN. That's one of the things I was attacking at the time. And so CAN bus, for those who don't know automotive, is basically a very simplified packet thing. So you have basically these simple packets that have like a source ID, instead of a source and destination, it's just an ID. And then up to 8 bytes is all you really have. And so that's one of the reasons they're really easy to reverse engineer, because they're only 8 bytes long. And being that they only have one ID, they basically run on a bus. So everybody sees everybody else's packet, which is nice. So in the past, the way these tools kind of work, they wouldn't release this information. And so this information was always secret sauce. And what they'd have to do is when there was an ID for these things, it would say like, okay, with this ID, second byte over, maybe third bit or something like that, it's going to be like the tire rotation. And with this ID, fourth bit over is going to be like, I don't know, the door locks. Okay. And so for every make, model, and year, they would define what that is. And that was all stored in a certain file. And that file is called a DBC file. Typically, that's the extension for that file. And that file is considered secret sauce. They changed it every year. And it wasn't necessarily because they're changing the parts every year. I mean, that does happen. But one of the other reasons they do is because they can then sell that file to tool manufacturers. And so for, instead of them using the same stuff, they now have to buy a new one. They make some extra money from it. And then, with that, because everybody needs that file, even people repairing it, those files get leaked all the time. Oh, we good?
Yeah, you're good.
Awesome, thanks, man. I think I have an example of one up here. And so you can kind of see they're very, very simple. This is the ID on the side, and there's from D1 to D7, or D0 to D7 are your 8 bytes. That's a fake packet. But you can see where that would be easy to reverse engineer. And so a lot of my automated tools, even though these are super secret and we can't release them, they wouldn't, even though they knew they were being leaked, they couldn't just tell you about them, which is what I really want them to do. It's just, if you bought a car, I would like to know what this DBC file is. Because the physical aspects of the car, only give you so much. What's actually running on the wires is really, really useful when you're coming to everything. Even from our perspective, it's from a security research perspective. Because without it, we have to now reverse engineer it before we can even get started, and that's just not that useful. So a lot of my tools were there to just automatically do that. It would do things like, this is the UDS sim, but they would do things like passive analysis. And so one of the things is if you don't tell anybody how things work, I don't necessarily have to know it either, especially if you change it every make, model, and year. Because if you change it every make, model, and year, that means if I just simply sniff and count the different packets and the frequency, that's unique for each make, model, and year. So I can passively listen on your CAN controller to figure out what kind of car it is. So some of the IDS systems that people were making academically at the time would check for things like when I would check a VIN number. So I could figure out what kind of vulnerability to use. Well, if I just sniffed and just passively looked at the traffic, I knew what kind of vehicle it was. And so I knew what kind of attack to use before I actually made the attack happen, which made it a lot stealthier. This particular tool, what this one did, took advantage of one of the areas that is defined, UDS, which is Unified Diagnostic. And what this one did is you would take this is one I gave in 2016. You take a dealership tool, or any kind of diagnostic tool, I guess, and you run it against your vehicle. It watches the network traffic. It sees what kind of diagnostic things are happening. It will then emulate the car. And so much so that the tool itself can't tell you're not talking to a real car anymore. At that point in time, it will also reverse fuzz the diagnostic tool to try and find vulnerabilities in the diagnostic tool. So you have an evil car. That evil car works really well because you may put some protections on your car, but you almost never put protections on the tool. And the tool has all the encryption keys to unlock the car. You should do that. If you're in that area, I'd recommend it. So it's on GitHub. So that's one of the things that it kind of works for that. But nowadays, if we fast forward, now I'm working at a company called Byton, and what they do is they make, the next generation electric vehicle kind of stuff, very IoT specific kind of things where we have really big displays, we have facial recognitions, all these tech in the vehicle. It'll come out at the end of this year, and so that's really fun. At the end of this, we can talk more about how to do things like hack a Byton, which will be fun. But the nice thing is, one of the reasons I went to this company as opposed to say some of the other companies is they did something a little bit unique. They had a security team early on. Actually, a lot of the members come here to Nullcon, as a matter of fact, and they got to work on a lot of the core portions of the vehicle early. And what they'll do is they'll make the prototypes first, the actual hardware prototypes first, and then pass it over to the hardware team to kind of make it more viable. And so it's a true security by design kind of aspect So it's not even just like the security team will look over things. They're actually building it alongside of the hardware teams. So that's a really, really unique thing that I would say for any company, not just automotive. Because typically a security team, you eventually, if you're lucky, you can get to a prototype before they're getting ready to sell it. But still, if you find something in hardware, even at a prototype stage, people don't necessarily want to change it. So it's tough. But if the security team gets to do the prototypes, well, that's a different story because you're kind of starting at a better, higher base. So that's one of the things I really liked about Byton. So it's like, okay, that sounds like a fun experiment. We'll try that. But as far as like the DBC files becoming open goes, while the security teams have definitely gotten better, like nowadays, that's still not a thing. Now, back in the day, I used to have to argue like we should do security, and it's like, oh, we already have safety testing. That's the same thing. It's not, and eventually they figured that out. But now I would say every single automotive company has a security team. And not only do they have one, I mean, it's not just IT. They actually work on the vehicles to different degrees of success, maybe, but they do have one, and that's good. But still, we have some of these very basic old kind of concepts like CAN bus packets and DBC files that are considered secret. But I kind of think that's going to change soon. One of the reasons is because while we went from super insecure car to security people like doing what we do, we've kind of caused a bit of a problem, or we're about to. And we do what security people do. We like to lock down all the things. We encrypt all the things. We use all the keys. We're like, oh, this is CAN bus. It doesn't encrypt. Let's encrypt that. How are we going to encrypt it? Well, private keys. We're going to put private keys. TPM. But side channel analysis. Well, we should make it against side channel analysis. And so we do our thing we do. And we run down the rabbit hole. We had all this extra security. But what do you do if you need to share that information? What if you have to give that key to somebody? How's that going to work? Why would you need to do that? Well, one of the reasons is because there's a right to repair, at least in the United States. But I kind of feel in general, as a consumer, you should have a right to kind of modify anything you've bought. So I kind of believe in the whole repair manifesto. You should be able to take things apart. You should be able to modify them. You also have insurance companies. And so they have actually, at least in the United States, a pretty big track record of being able to get into their information, because if you're going to take your vehicle to somewhere else to get repaired, that needs to happen. Insurance companies need to know things like, were you driving the car, or was the car driving itself? And today, most of the stuff's kind of in the cloud or it's in a proprietary format. So you'd have to ask, like, I'll pick on Tesla. You have to ask Tesla, like, hey, was the car driving itself? Like, oh, no. And so it's not quite that simple. But in a way, like, there isn't a way to kind of third-party verify things. And as we move more and more to the cloud, we have more smart devices and more encrypted stuff, this becomes harder and harder to do. So currently today, with normal vehicles, we can reverse engineer these packets. We can make third-party components. We can service things afterwards. But as we encrypt things, as we move more things to the cloud, you won't be able to do that anymore. But they still have these rights. So how's that going to be resolved? And this doesn't even deal with all of it. We have things like, let's say something about this guy. This is Corey. So one of the things here is, like, we do have a solution that we can use for, say, insurance companies. Even some of the right to repair with the cloud-based stuff. One of the things the right to repair people are kind of complaining about is, what if, like, if you keep putting things up in the cloud and then you can send the reminders to customers that, hey, you need to come into an oil change. Like, we're not in that loop anymore. We can't give people the same notifications you can give. You have an unfair advantage. And so one of the things you can do as a consumer is you could approve that kind of information to be sent somewhere. And so it could be sent to your local mechanic so he can give you the reminders instead. It could be sent to the insurance company for a week. That would prevent having to do things like these dongles you used to plug in. So Corey hacked one of these dongles. The dongles are notoriously easy to hack. And these are basically devices that people are plugging into their vehicle directly into this CAN bus that nobody could test it against. Even if you made a nice secure car, you'd have to basically block this out. It's the only way to kind of know what's being directly attacked or attached to that. And so that will eliminate that attack vector, which would be good. And so we're getting there, but that still doesn't solve our problems. We still have the issue of the aftermarket. So even in a situation where you provide all this stuff, the vehicle manufacturer, they only support the car for about 11 and a half years. Now, it doesn't mean the car stops working in 11 and a half years. People have had older than 11 and a half year cars. That's quite common, actually. But the way that works is aftermarket takes it on. So they take on all the part repairs, all that kind of stuff. Well, if everything talks to the cloud to basically function, how does that work? That's a much harder problem to solve. I mean, you can't just give them your cloud. If you're using everything with private keys, are you going to give away your private keys at the end? Did you use the private keys for more than just that car? That'd be a problem. And then, if you do give out, like, do you have a list of who you're giving out, or are you just going to publish that on your website? Like, here's our private keys. Like, I don't know. What is your solution? Most people don't have an answer to this. And there's also the case, like for instance, I'm in Byton. It's a startup. Of course, we all want to think it's all going to live and be awesome and forever and all that good stuff, but it could very well be gone in 3 years. Does that mean the car turns into a brick? But that's one of the things that kind of happens. And so as security people, what we have to do is we have to figure out how can we make things secure and yet still hackable, right? So we still got to protect the bad guys from modifying, because we can't just turn off all the security. We can't have somebody doing a man-in-the-middle attack on a vehicle while it's trying to self-drive, or you can't have somebody, get in and change the firmware on you. You don't want anybody to steal your vehicle, those kinds of things. We still have to stop those things. But if you're the consumer and you bought that vehicle, you should still be able to make modifications to it. And so this is an area that in order for somebody to own a piece of property that they are paying for, they need to be able to make modifications. And as us, as security people, we have to solve this problem. And I don't think there's a really good way in the industry right now to say, oh, here's a company that's doing it right, makes it very easy. We'll talk about it in a bit, but it's definitely hard. No, I can't talk about like what some of the other companies are doing, because I've worked for them, I have NDAs, and I have one for Byton too. I do know I'm allowed to talk about some of these things. So I can talk about Byton's. And so one of the things that we have is, we have the ability to grant access to pieces of data. And so we can grant access for like insurance companies. We could grant access for third-party mechanics and whatnot. The way it would work is we have a phone app, and we also have applications you can put in the dashboard. It's a big screen. So we can select that and say, okay, we're going to grant this insurance company a week's worth of access to the data. We also have the option of selling blank ECUs. So when we have these secure gateway kind of things, those have the things that security people put on those things when we're the ones that left to design them. So they have tons of encryption capabilities. They have TPM devices. They have all these things. Well, that would make it really, really hard for somebody else to modify it. So one of the solutions is we can sell you a blank one, not locked yet. You get to lock it. You can put whatever code you want on it, and they're not that expensive when you're buying a blank one. So that's an option. We also have warranty voiding fuses. So, when you have we have these fuses built into the chip. That's what I'm referring to, as fuses. And so a lot of times these fuses are used for things that prevent rollbacks. And so if somebody's going to push down a firmware version, and then you're like, okay, well, I can't have this old one run due to some kind of safety bug, whatever it is. You can blow a fuse so that you can't put the old version on anymore. We've reserved some of these fuses to allow for warranty voiding fuses. So when people want to go modify something, they can, and we'll just blow a fuse and say, okay, you can modify it, but we know you've done it. And so therefore you can't bring it to us and say you're the one who caused this issue. Because that kind of happens today. So what we'll have is we'll have performance tuners and whatnot, and maybe they'll go in, they'll modify the ECU, and then, they'll blow up their engine or whatever, and they'll put the original firmware back on it and bring it to the shop and go like, you sold me a piece of crap. Like, hey, replace this for free. And, that happens. It's called insurance fraud. But it's really popular, unfortunately, in the performance tuning area. And so this allows you to make modifications, but you can't do the insurance fraud piece, which I do think is important. And, we do want them to be able to make modifications because they may make cool inventions, and I think it'll help sell the car, but we have those. And while those sound nice, they're really not enough. So for instance, we don't have any kind of standardization for our data. So while we can say, okay, insurance company, you can have this, if you ask the insurance company what they want, they don't actually know. There's no API to look towards. So, by the way, we're building a car that's coming out at the end of this year, so we're just kind of guessing this. They probably want this. That's not the best way to go. We don't really have a choice at the moment, and so ideally, maybe if we provide something, other people will just, if it's easy to use, will hopefully just adopt it and it'll become a standard, and it won't be a problem anymore. It may still be a problem, so we'll see how that works. That open ECU, we're like, hey, you get an ECU with all this cool equipment and you can do encryption and whatnot. That's awesome, but today there's no open source ECU that would work on our firmware. So I don't know what good that's going to do. I mean, maybe that piece will fill in, and I'll feel a lot better about that solution. But right now, I'm basically selling you a brick. Like, oh, here you go. Here's a blank board. Don't kill yourself. It's kind of awful, but that's better than what other people are doing, I guess. But we're still not where I want to be at yet. Because the thing is, there's a lot of part of that operating system that's been tested and worked on, and you probably don't want a blank one. You just want to make some kind of modification. So that's where the fuses should come in at. Because I can say, okay, we can give you the operating system, but you can blow a fuse so you don't, disband your warranty for maybe the entire car, but maybe just a portion. Maybe you just want to make a small change. You want to do something. We only have so many fuses still on these chips. So how many to reserve? What do we reserve them for? We have our own boards, but we also have a lot of these, also called ECUs, inside the vehicle that are also programmable. Like, those are things you're probably going to want to swap out at some point in time. Maybe you don't like the factory one. We want to rev it up, make it nicer. We want to let you do that. But there's a lot more of those ECUs than we have fuses. So how do we do that? How do we make that look? We can give you things like a key for it. So for instance, if you just want to make modifications, let's pick an example like a smart strut. And so a smart strut that's maybe operating a lift gate. And so you've added stuff to the back of your lift gate. And now you want to tweak it out so it can, lift better and whatnot. Maybe we're going to let you do that. Maybe we're going to give you the keys to let you update the firmware any way you want, but we're going to blow a fuse for that. And it's mainly because there's pinch sensors and whatnot on a liftgate. If it crushes some child's head, you change that, not us. So we have to basically tell people that. So we could do that, but then we give you, the passcode for it, and then it's fine because each one in our vehicles is different. So that's fine. So every one of ours, you're only getting it for that one smart strut. But what if so one thing I didn't talk about is if you have multiple devices, old school devices typically use a seed key thing. And so the way it works is you say, hey, I want to update your firmware. It gives you this challenge. It's 4 bytes. It's like, okay, here's this challenge. It's usually 4 bytes. It's 4 bytes. And then you go, okay, I run my secret sauce algorithm. I go, okay, here's your answer, 4 bytes. So, and then they match, overwrite the firmware. That's how the car industry pretty much still works. And so it's as simple as stupid as you think. So if you do really, really complicated math, you still get 4 bytes no matter what. That's your key space. Very easy to crack. Very easy to make rainbow tables for too, no matter how hard the algorithm is. But the thing that makes it tricky for us from this perspective is if I give you the magic number that you need to do to override it, that's fine. But what if you want to replace that device with your own smart strut? I want to use my other one. Well, I don't know their algorithm. There's no way we would know what you're going to place in that car at the time we built our car. And so it's not so easy. I can't just replace my ID or my key with yours and it would just start working. So how do we do that? How do we pass that through? So these are things we have to kind of solve. And then some of these devices are more complicated too. So our gateways, our infotainment centers, those kinds of things, they're going to run Linux, Unix, Android type of stuff. What parts are you going to want to modify? If it's a piece of firmware that's smart, I want to modify the map injection table or something like that, for fuel injection table. That makes some sense. But when it's a full Linux distro, what do I give you access to? It's I don't mind doing it, but I'm not too sure what to give you. I don't know what that needs to be, where it needs to live. So while we're reserving things, we're trying to figure out how this is going to work. I'm really, really looking for feedback because we don't have this solved. And I don't know anybody who currently does. And so this is, a big group of smart people. And I would like to kind of get some feedback from you guys. So I'm going to take the chance. Hopefully you guys aren't too shy and kind of ask around. If there's things that you're thinking about that you think may be a useful way of allowing security, but still allow people to make modifications. I'd really like to hear it. Can anybody raise it? There's no wrong answers too. You just raise your hand, I'll call on you, and you can give me some kind of examples. Yes.
You can do it something like what's done on pretty much on commercial phones. So you have various levels of certificates which are allowed. So a user certificate has got certain level of access, whereas OEM certificate is a step deeper.
Mm-hmm.
And manufacturer certificate gives you a whole lot level of HL extraction access. So you could implement something like that on the ECU side, which you can filter at the OEM level.
Okay.
Various degrees of.
Yeah, so you have multiple certificates at different levels, solved at the OEM level. So you would, I would say the OEM would give out different certs. Hey, your user cert, you can modify certain things with this cert.
Yeah, you use some kind of application to get the cert in maybe
Like a proof of ownership.
OEM software patch or something, which you can load onto your
I like that.
and then access that functionality.
So I like using multiple certs. I think that's good. Now, what happens if, like, say, Byton doesn't exist in 3 years? How do we give out certs? Yeah, everybody loves it when their company's still around, but like when their company's not around, like, that's when the challenge is, right? Like if that car, or even like in the car, like 10 years, we don't support it anymore. Like, do we have to keep that infrastructure going? I don't know, but I do like the cert thing. We've definitely been playing with that too. Let's try to figure out if that's an option there that we can use. Like multi-sig is something we've been thinking about. Escrow, maybe an escrow system. We've also been toying around the idea of maybe using, like, you have like a third party, kind of three people necessary to make a change. Like maybe Byton's one, maybe like a right to repair alliance is one, maybe the consumer is the third person that holds it. And so 2 people can agree to make a change. If Byton's not there, right to repair, and that person can decide to do their thing or whatever.
Engineering backup service guy with whom you validate that change. I as a consumer can make that change, but I can operationalize that change till it gets validated by the service guy. I can sign it on or enable it.
Okay. So you're suggesting like you make a
So it's a blown
recommendation?
concept, but
Okay.
it's slightly different.
Yeah, and the service guys involved, like, are they like the OEM service guys, or can it be like anybody?
Depends. That's a business model thing. But,
Okay.
but the concept is the same.
Oh, nice. Okay. All right. So the service guys can validate user changes, and then once they're okay, then they go
You
through.
can do it online over there or whatever it is.
Gotcha. Cool. Well, that's awesome. Is there any other ideas back here?
Just like to unlock our whole bootloader, we have to submit a code to Google or let's say as an OEM, perhaps cars and
So you would submit a code like through the infotainment display or through a mobile phone. That's like this is my car, and
yeah, so for example, like in case of Sony and other devices, in order to unlock their bootloader, we have to like submit a special code. I forgot like how to obtain it, but basically we have to submit that code to Sony's website, and then they provide one more code which we have to submit to ADB, I think, and then we go to the other.
okay.
Maybe something like
Yeah. I think you could do a code kind of thing to get an unlock. There almost has to be kind of a local way to do that, though. Like if you're physically on the car, no cloud-based system for that. Because again, if Byton's gone, I can pick on Byton because I work there. So if Byton's gone, they don't exist anymore. I need to be able to take my car and go like, I need to use my cloud services that I bring up in AWS or something. I don't know how that's going to work yet, but yeah, there needs to be something I can query or to kind of prove like, hey, I'm on the car. I'm not stealing the car. It's me. Now I need to get that unlocked. Yeah, and I've seen some phone services, and I do actually like the Android model for a lot of these things, where you kind of have like your phone, and then like you plug your laptop in, you authorize on the phone, like you put your passcode in, you say this computer's allowed to talk to it, and then on the computer you can bring up ADB, and then you say I want to root it, like a Pixel type. Well, I don't know if Pixel does it. Nexus used to do this. You say I want to root it, and it says you're going to void your warranty. You sure? And you go yes, and then you're good. And I kind of like that. I would like to get something like that for a vehicle. I think if we can figure out how to do that, that'll be awesome. That's kind of my goal. I just don't know how that's going to look yet.
So there is a way that's implemented now in exactly this manner you said on the device side. So there are various engineering codes which essentially give you the same certificate access which I mentioned. So if you punch in XYZ code for a particular model, it will give you that level of access inside that device. So you don't have to go to the cloud to do that. But you need to know the code. But however, the downside is from a security point, I can pass it on to somebody else. So there has to be some tie-in to that specific car so that it's not global.
Yeah, so like a local certificate, like validation piece.
Some other validation has to happen at the local end.
Yeah.
But on the device side, there isn't anything like that.
Okay. Yeah. I think we need to do this type of stuff, and I think we actually need this for all consumer electronics in general. We need to get to the point where maybe we can get to a standard version of it. I think that would be excellent. You got a question or statement?
I like the Renault model. So in Indian Renault cars,
Yeah.
specifically like the lower end models like Twin, so what they do is they have media unit and the radio. They monitor the state of the car. So the moment you want to tamper with the ECU, The first one check on the complete firmware image, recalculate checksums, and see the state of the radio. If the radio is called up and the user has implemented his own version of code, then the ECU will stop working. Okay. So in order to reflash that, we need to get in touch with Reno, get a code, reflash the image of the media event, and then you can make the modifications. I know it because I have a quit and I specifically. Void my warranty. They said, no, you can do it, but it's on your own risk. But if you want to bring the car to us, make sure the original firmware image and the original radio is intact.
Interesting.
Yes.
Yeah, I like that.
Specifically for the CMF-A model and CMF-B platform on this liquid and your Ready Go, that's Ready Go. It is working. So there is an indigenous model and it is not sold anywhere else except in Brazil, where a special where the video unit is different and it has support for multiple TPMS and even the airbag splitting or Asubiritsu models as well. So it is different there, but in India it is happening.
Oh, nice. That's good. Good. I like hearing that it is actually going on somewhere. We're getting some kind of progress on that. Just at the end to kind of help you guys out with some things as a bonus also for helping out here. We can do a attack surface on one of the new vehicles coming out. So this is one of the Byton vehicles. We can do a question and answer kind of thing. Not the car here, obviously. But to give you an idea, we have large displays here. We have multiple displays in the back. We actually have one on the steering column. There is a gesture control thing in the middle here. We obviously have key fobs. We have facial recognition. And for this little game, what I'll let you guys do is if you guys want to say like, hey, if you were going to hack this car, we do a quick threat model. I can tell you how it works in different pieces, so at least to a large degree, and not everything maybe. And there's still some things that have to be decided. But yeah, we can do this little game for you. We can figure out like how would you hack the next generation vehicle as they're coming out. So what kinds of things would you think of for hacking the Byton? Anybody? I can start you out if you guys want. So like if you were to go after like USB. So a USB, there is USB in this vehicle. It is on the, I don't know where it's physically at the time. I see that on a board basis. But it does exist. But the data channels have been removed off of it. So we don't have data access to our display. We do have power. You can basically use USB to charge. Could you use power voltage on or power glitching on it? Probably.
Within a specific limited voltage level, and there's one more thing. When we talk about USBs, okay, there are some particular attacks. I would like to know that what is running inside. You know the Tesla leak in which the engineer actually holded an AMA on Reddit and told out that how the firmware was being.
Oh yes, yeah. That's a Tesla leak. Mm-hmm.
So I had some interesting attack surface details there. So I was just thinking on that count. Because again, when you're looking at level like USB, definitely there has to be a control for that. So that we can, identify how quickly it is interacting with it and most of attacks on that part.
Yes.
Just thinking out loud.
Yeah, no. That's what we should be doing. Is thinking out loud on different ways of attacking it. So we have power glitching as one. I'm sure you can do power analysis on it as well. So differential power analysis. I mean, it's going to be very noisy on the USB port. Now, if you get past the USB port, you actually take it out and get to the boards. It's going to be a lot easier. But a nice, very cool hack would be through the USB because you do have the power there. So if you could sort through the noise of it, which would be difficult, but you could potentially do it. I think that would be a pretty cool hack.
Something like rubber ducky.
Hmm?
Something like rubber ducky. Rippling inputs. Code injection.
We don't have data, so there's no data pins. So yeah, you won't be able to use a rubber ducky on this one. So you couldn't do that. We do have different Gs. We have the theory 5G, but obviously it's not out yet. But it is capable of doing something like that. It has Wi-Fi capabilities. We have Bluetooth.
Either access point, I'm not sure, it is represented in India. saw some cars outside India on which we can simulate the access points and something like that, or if the car can connect to it. Spoof that thing. Or if we have Bluetooth, recently we found a bug in one of the Suzuki units in which we were able to overflow the Bluetooth unit and it got reboot, it went to a reboot loop. But that's again a bug. Again, that is an interesting attack surface because probably that was using a name, I forgot the name of the unit. If properly further and properly investigated, because we get limited access to it, we may be able to have some command injection capability on that Bluetooth unit. But how far will it go? I'm not sure, because I'm not sure that how exactly it is interfaced with the ECU and the canvas system. Because again, it is on the peripheral side.
Yes, yeah, and we have CAN bus in this as well. We have Automotive Ethernet and CAN bus, and so there are pieces we'll be able to use standard UDS for it. They are protected for the most part from externally by the gateway. The gateway doesn't unlock all those. Mainly that's for handling like over-the-air updates because the gateway handles a lot of the over-the-air updates for you because they can update those ECUs. So in theory, for a lot of it, one of the things we can do is we can basically do the relaying of diagnostics we need to for other people. And so therefore you can use like a smart app or something like that as opposed to having to buy a special tool and all that kind of stuff. Now we may end up doing a thing where you do buy a special tool anyway, for whatever reason, and then we use the gateway to pass through. And so if that happens, if we allow pass through, you might be able then to, once you've authenticated and opened that window, then you could probably do a similar attack to that Suzuki where you're exploiting that kind of stuff. So I think there's a way of doing it. It's not super simple. You can also tap into certain lines, I would say. If you bypass and you were to track where those lines are, you could probably get into that to exploit individual ECU units. Yeah, those are good. Those are all really good. Anybody else want to shoot a tech? Oh, you can also ask me questions right now because I think we are getting close to the end here. So if you have any other questions too about hacking, cars, biting, whatever, resumes, those things are all good. Anybody? Okay, well then we'll just go ahead and wrap this up then because we're about that time. All right, thank you guys. Thanks.